Hi everyone. Now let us continue with the second question in gravitational force and field strength. Okay. 2-point masses X and Y of 25 kg and 15 kg are separated by a distance of 4 meters. Okay. So we have 2-point mass X and Y. Find the magnitude and direction of the gravitational field at point P and Q. Okay, I need to find gravitational field for 2 points for P and Q. So what the question requires us to find is the gravitational field, which is AG. Okay, want to find the magnitude and direction. So this is a vector. Yeah. So gravitational field. What's the formula? Gravitational field actually is this formula. We use this formula. Gravitational field equal to Gm over r square. Okay, Gm over r square. The mass is actually the point mass that provide the gravitational field. Okay, so make sure you use the correct mass. Use the point mass, not the test mass. Now, I put in the information given. We have mass x and mass y, which is given here. Mass x and mass y. Okay, now we want to find the question A. We want to find the gravitational field at point P. Okay, at point P. So clearly we have 2-point mass here. We have point here we have 1-point mass. At Y also have another point mass. And both of these mass, they provide gravitational field for P and Q. Okay. Now let us look at P first. Okay, so let us first draw the gravitational field for point P, okay, given by X and Y. All right, so it should be okay, AX, gravitational field is attractive. So attract towards X, this is AX. And then Y also attract towards Y, AY. Okay, so and then we must put in the symbol, the sign, okay, to the right positive, to the left negative. So the positive negative sign to show the direction, very important. Okay, so next we can continue with our calculation. So AY is positive. Sorry. Oops. Okay, AY is positive, and then AX is negative. Okay, AX is negative. So now let us apply the formula Gm over r square. Okay, Gm over r square. So AY is G mass Y. Okay, it's a mass Y over Ry square. Okay, negative Gmx over Rx square. Okay, then we can factorize out the common, which is the G. G factorized out, so easier for us to solve the question. So mass y over ry square negative mass x over rx square. Okay, now let us substitute the value. So G is 6.67 exponent negative 11. And then the mass y is okay 15. Because this is the point mass. Mass y is 15. So just put in 15. And then ry, how far is P from y? P from y is actually, from here to here, it is 2 meter. From P to X is also 2 meter. So we need this value, yeah? So the ry is 2 meter. So just put 2 square. And then mx, mass x is 25 kilogram. So put 25 kilogram. and then 2 square. Then we calculate, we will get negative 1.67 exponent negative 10 Newton per kilogram. Okay? Or, okay, gravitational field strength actually has 2 units. You can either put Newton per kilogram or meter per second square. Okay, yes, 2 units. But normally, Newton per kilogram refer to gravitational field strength. The meter per second square refer to acceleration. Okay, gravitational acceleration. So this question asks about gravitational field strength. So better you put Newton per kilogram. Okay. So this is the answer. Okay. But you need to give also the direction. So negative means to the left. The resultant is to the left. That means AX is stronger than AY. That's why the resultant is to the left, towards X. So right there, your direction towards X, yeah? Or you can write to the left. Okay, that's the answer for direction towards X. Yeah. Now, let us do the part B, which is a gravitational field at point Q. Okay, so at point Q, where is the direction of gravitational field? Okay, I redraw over here. Point Q, X and Y. Now, let us first draw the gravitational field by X. So, attract towards X. Okay, gravitational field is a vector, you must draw arrows. So this is AX, and AY is towards Y. Okay, this is AY. Okay, so and then you need to, this one is X and Y axis. You need to resolve AX and AY into XY components before you can continue doing. Okay, so I want to resolve, right? So I resolve, sorry. Okay, I need to resolve this into components. Oh, but I need the angles. I need the angles before I can resolve. And also I need to find the value of AX and AY before I can resolve. So first of all, you need to find, okay, AX and AY. Okay, let us continue with finding the AX and AY. So AX is equal to the formula GMX over RX squared. Okay, so what is mass X? Mass X is 25 kilogram. Okay, so 6.67 exponent negative 11. Mass X is, 25 kilogram. So just put in 25 kilogram over Rx. Rx, that means how far is Q from X? Oh, I need the distance. So, okay, I redraw here. This is, we want to find distance Qx because in the diagram we have QP 2 meter, XP 2 meter. So, this is the one, yeah? This is, here is actually point P. Okay? So I want to find Qx. Okay? This is actually the Rx. Okay? This is the Rx. And of course, this is the Ry. Okay? From Q to Y is Ry. So what is Rx? This is right angle triangle. So this is also same these two and same side, 2 and 2. So we can say we got the angles. This one should be 45 degree. This one also should be 45 degree because it's same side. Okay. So yeah, we can use Pythagoras theorem to find the Rx. So which is square root 2 square plus 2 square, and we got, what do we get? What did we get? 4 plus 4 is 8. So it is third 8. Third 8 is Rx. So I think Ry should be the same also. Yeah, third 2 square 2 square. So this is third 8 also. And this is 45 degree, and this is also 45 degree. All right. Okay. So now we got that. We can find the value of Ax because we already got the distance. Okay, so this is third 8, but don't forget the square. Many students forget about this square. Yeah, they forget to square it. And what's the answer for Ax? Ax is 2.0844 exponent negative 10 Newton per kilogram. That is for okay. I think we shouldn't put ax because we try to denote this as 1 and this as x as 1, y as 2. So better we put this as a1 instead of ax, because later we're going to use the x component and y component. So it's a bit so just change this to mass 1 and r1. Okay, 1 1. All right. So this is just put this as 1. All right. Just put this as 1. Oops, sorry. So this put as 1. This is as 2. You know, this is x and this is y lah. Okay. Yeah. Just put this as 1. This is 2. Okay. Come on. This is 1. This is 2. All right. Better. Yeah. So now let us continue. Find A2, which is AY. Okay, so A2, okay, A2 equal to G mass 2 over R square. This is using mass 2, which is the mass Y. Okay, so let's continue. Our G is 6.67 exponent negative 11. Our mass 2 is 15 kilogram. Okay, it is 15 kilogram. And R2, Ry is also 2. So this is 2. So what do we get? We get 1.2506 exponent negative 10 Newton per kilogram. That's the A2. Okay, that's the A2. Now, we got the A1 and A2. Okay, maybe this one we can put as A1, this one as A1, this one as A2. Now we can resolve into x and y component. Okay, resolve this into the x component and y component. You know, that's why I don't put this as x and y, because we have x and y component. We would want to get confused. Okay. So, oh, okay, we already have the angles. We have the angles. This is both 45 degree, 45 degree. So we can resolve. Remember to put the sign going to the right, positive, going upward, also positive, left, negative, downward is negative. Okay. So now let's get the x component, ax. Okay. So let's find the total AX, which is the horizontal component. Total AX, we have A2, positive A2 sine 45 and negative A1 sine 45. So we have, all right, where is it? Okay. Okay, let's continue. So our total AX is we have A2, positive A2 sine 45 and negative A1 sine 45. Okay, positive A2, A2 sine 45 and negative A1 sine 45. Okay, so let's substitute the value and we will get the answer negative 5.8959 exponent negative 11 Newton per kilogram. Okay, that's AX. Now AY. Let's get the AY. Total AY is equal to total AY equal to, okay, AY, the Y component we have negative A1 cos 45 and negative A2 cos 45. Okay, so negative A1 cos 45 and negative A2 cos 45. Yes, that's it. Yeah, cos 45, cos 45. And what do we get? We will get negative 2.3582 exponent negative 10 Newton per kilogram. Yes, that's AX and AY. So this one is going to the left and this one is going downward. Okay, X going to the left, Y going downward because they are both negative. So let's find the resultant. Let's find the resultant. We have AX here, yeah, negative, and we have also AY negative going downward. So our resultant is in this direction. This is total A for P. Okay, total A for no. Total A for Q. Okay, that's Q, not P. So this is a total A for Q, and we need to find the angle theta. The theta is below the negative x-axis. Okay, let us find the total AQ. Total AQ is equal to the Pythagoras theorem of AX and AY. So just take the total AX you square plus total AY square again and square root, and the answer is 2.43 exponent negative 10 Newton per kilogram. Yeah, that's the magnitude. Now the direction is find the tangent theta. You must get the direction also because it's a vector. So tangent theta is AY over AX. Yeah, no square. Okay, so just take the AY, the AY over AX, modulus and anti-tangent, and the answer is 75.96 degree below what? Below this, below the negative x-axis. Okay, so that's the answer. All right, so you get it correct. Yeah, 2.43 7596. 2.43 7596. Yes, that's correct. Okay, so that's how you find the resultant gravitational field strength. You must use the vector method. Remember, you must draw arrows. Use the vector method, do the x component, y component stuff, and find the magnitude using Pythagoras theorem and tangent theta to find direction. Just treat the gravitational field as vectors. All right. This is how you draw for vector. You must draw arrows. You must draw arrows. You must draw a vector diagram. Do x and y components. All right. So stay tuned for the following videos. Bye.